Remember that in covalent bonding, or molecules, there are two electrons being shared by the atoms if there's just one single bond. Well, we're going to see whether or not those electrons are shared equally. And the way we do that is by using the electronegativities, or the tendency of an atom to gain an electron, to figure out whether they'll be equally shared. For example, we have two hydrogens here, and we look up their electronegativities on the periodic table, and we find out that they both, of course, would have the same electronegativities. So they both have an electronegativity of 2.20. So what we'll do is we will take the 2.20 of one hydrogen and we will divide it by the total electronegativities if you add them together. So we will take 2.20 divided by 4.40 and multiply by 100, and you will notice that 50% of the time it's with one hydrogen and 50% of the time it's with the other hydrogen. That's what we call equal sharing and what we call a nonpolar bond. There's no unequal sharing there. Let's take another bond between carbon and oxygen. Now we know these two won't have the same electronegativities. In fact, carbon has an electronegativity of 2.55 and oxygen has an electronegativity of 3.44. Oxygen would like that pair of electrons more often than the carbon. So let's see. If we take the carbon's electronegativity and divide it by both electronegativities added together, we find out that carbon is only going to have the electrons 28% of the time. That means that the oxygen is going to have it 72% of the time. So 72% of the time, or most of the time, the electrons are going to be found with oxygen. And since electrons are negative, that will give the oxygen a slight negative charge. Notice the symbol. And it gives the carbon a slight positive charge because the electrons aren't found there 72% of the time. That gives us a polarity moving towards the oxygen because it has the slight negative charge. That's what we call a polar bond. There's an easier way to do it other than that. If you look at the electronegativity difference between the two atoms in the bond, there's a chart you can use to figure out whether it is a polar or nonpolar bond. If the electronegativity difference is less than 0.5, we consider it to be a nonpolar bond. If it's between 0.5 and 1.7, we consider it to be a polar bond. If it's in between 1.7 and 1.99, we consider it a polar bond unless it has a metal in it, and then we consider it ionic. If it's greater than 2.0, we go ahead and consider it an ionic bond. So let's look at this example here just to show you how easy it is. The oxygen has an electronegativity of 3.44, the carbon an electronegativity of 2.55. If we subtract them, we get an electronegativity difference of 0.89. If I look up on the chart, that falls within the polar covalent range. So that is a polar covalent bond. In this section, I'm going to show you why it was important we drew our molecules in the correct shape. In order to tell whether a molecule, not just a bond, if a molecule is polar or not, we're going to have to look at the shape and determine whether or not there is a chance of it being a dipole molecule, meaning that one side of the atom will be negative and one side will be positive. If you look at this molecule here, you'll notice it looks pretty symmetrical. And the way we determine whether a molecule is polar or not is to divide it in two different regions. Let's first divide it in left and right, and we look at the atoms on the left and right side. They're both oxygen, so there's no difference in electronegativities. If we divide it in the top and bottom, we have no difference in electronegativities as well. This molecule is made up of two polar bonds between the carbon and oxygens. Because this molecule is exactly symmetrical both up and down and left and right, we consider it to be a nonpolar molecule made up of polar bonds. Here's another example. This is formaldehyde. You'll notice that if we divide this from left to right, there's no difference whatsoever. But if we divide it top and bottom, the top atom is an oxygen and the bottom atoms are hydrogen. Clearly a difference in their electronegativities. So since it has an oxygen on top and hydrogen on bottom, we're going to say that the polarity is going to shift towards the oxygen, or the electrons will be most found towards the oxygen, so we consider this a polar molecule, also known as a dipole. Here's another example that I wanted to explain. If we divide this left and right, clearly no difference. But if we divide it top and bottom, a lot of people think that since there's 3 hydrogens on bottom and 1 hydrogen on top, it would be polar because there's a difference in the number of hydrogens. But you have to think about it is that there are only hydrogens on top and only hydrogens on bottom, so the electrons are being pulled the exact same amount away from the carbon. We still consider this a nonpolar molecule.